Hi, this is Jared Wright again, your instructor for Introduction to Sociology. This is part 2 of our week 1 video review, and I'm just going to talk about some of the things from chapter 2 here. Chapter 1, I talked about the sociological imagination and some of the important ideas behind sociology in general as a science. Chapter 2 covers specifically how we do sociology, and our research methods, basically, the methods of science that we use to gather our results and do studies. Um, so there's a lot of very important concepts in this chapter that you need to read about very carefully. There's some good definitions in here. A lot of it really is about the scientific method in general, things like hypotheses, dependent and independent variables, deductive and inductive approaches. That can be applied to any type of science. But these are important things to know. Quantitative and qualitative methods are particularly important within sociology because we use both. A lot of sciences only use quantitative approaches, but in sociology, they complement each other very well. For example, a quantitative method is more something based on numbers, something oftentimes statistical, like doing a large-scale survey where you can reach hundreds or thousands of people and then doing some kind of statistical analysis to come up with results from that. Um, Qualitative methods would be something more like doing an in-depth interview with someone, or what we might refer to as participant observation, which basically means spending time with a certain group of people in order to observe them and participate in their activities to learn about them, and taking very detailed sort of narrative type descriptions from that. So they definitely complement each other because, quantitative can reach a lot of people with a survey, for example, but you may not be able to get really in-depth information from those people. You may not be able to get a lot of detail. You can only have a few questions with maybe a limited number of responses. Um, Whereas with quantitative methods, it takes more time and you don't get to reach as many people, but you can get much more detail, much more in-depth about very specific things. So oftentimes these days you see people doing what we call mixed methods, which is somehow combining quantitative and qualitative in some kind of unique way. But we try to use both of them as much as possible. Another very important thing that I want to point out here is the difference between causality and correlation. This is something that people confuse a lot. Um, when we do statistical tests, we're oftentimes looking for a correlation between two things, which means we're looking to see that two things are both sort of changing the same at the same time. But proving causation is much more difficult. Um, for example, there's this website here that I found. This is an example. This has a few examples actually of some items that are correlated but are not causing one another. It's what we call spurious relationships, which the textbook also talks about. So, for example, you can see here the amount of ice cream sold and deaths by drowning. These very strongly correlate with one another. They both skyrocket during the summertime. And actually, it turns out it's a spurious relationship because the real causal factor is the season. Because in the summertime, you have more people eating ice cream and you also have more people swimming, which means more drowning deaths. So ice cream and drowning are not, there's no causal relationship between those two things. But there's actually this third factor, which is causing both of them independently. Therefore, we can say the relationship between ice cream sales and drowning deaths, even though it's strongly correlated, it is a spurious relationship. So this is an important thing to keep in mind. There's a very distinct difference between correlation and causation. Um, just another little fun example here. These are things which are correlated, but are not connected by causation at all. For example, the number of the number of people who drown by falling into a pool and Nick Cage films. Pretty highly correlated here, but you can't really argue that one of these things is causing the other. Or maybe you can if you're very creative. I don't know. But there's a lot of really funny ones on here, like per capita cheese consumption very highly correlates with the number of people who die becoming tangled in their bed sheets. But again, there's no causal relationship there. That is only correlation. So in order to prove causation, as the textbook says, it's very important. You need three things, one of which is correlation. You need correlation to begin with, but you also need to establish that there is a timeline. So in order for one thing to be causing one another, you have to be able to show that that thing has changed over time. So you have this item B, and then you introduce A, and then B changes after A was introduced. That's a very important part of being able to establish causation. And then the third thing is just basically being able to discount other alternative explanations. But yeah, it's extremely tricky in social science to really be able to prove causation. So oftentimes we confine ourselves to only talking about correlation and trying to hypothesize about that. Now, there are some issues as well that you should be familiar with in doing social research, such as validity and reliability. Validity refers to basically that you are testing or measuring the thing that you think you are when you're doing a social research method. For example, there's been some controversy around like IQ tests, for example, because IQ tests are supposed to measure a person's intelligence. But in fact, some people argue that IQ tests really just measure how good you are at taking tests. So it's not a very accurate measure of how intelligent a person actually is. Some forms of intelligence really can't be measured on paper by standardized tests like that. For example, like how many of you know somebody who is really smart and took the SAT and did terrible on it? Or the other way around, somebody who's maybe not that bright but took the SAT and got a really good score. You know, it's not always necessarily a completely valid form of measurement, and so that's something that we have to be careful about and pay attention to. Another reliability refers to being able to reproduce your results over and over again, which is also especially tricky when you're dealing with people, because people are very unpredictable. Even the same person taking the same tests multiple times may have very different results. But it can also have to do with how your experiment or your survey instruments are designed. So that's something you have to pay attention to. Generalizability is another important issue as well. And this is a particularly tricky one. You know, we oftentimes want to get results that we can generalize to all of society, but this can be very difficult. When you want to generalize to a larger group, we call that the population, is the larger group that you want to talk about or get results about. But you can't exactly go out and talk to every single person in the United States, for example, if that's the population you're interested in. There's just too many people. I mean, there's something like 120 million people in the United States today. So what we do in social science is based on statistical probability within a 95% confidence interval. We come up with what we call a sample. We use sampling tactics. And a sample means that you draw a smaller number of people from your population, and it has to be a random distribution of people in order to be able to capture the true diversity within the population itself. And that sample then becomes representative of the larger population. That way you can do a survey of a certain number of people, and then you can generalize those results to the larger population. Now, if you're dealing with a population as large as the United States, you still need a pretty large sample. And there's actually some very sophisticated algorithms which are used in statistics to determine the exact sample size you need. For a 320 million person population, your sample size would need to be something like 38,000 or more. And yeah, that's a lot. So you see, like the U.S. Census Bureau, for example, the census tries to come up with results about the entire country, and so they send those censuses out to everybody. And they go knocking on door to door and trying to get as many people as possible to respond to those, so that they can get truly accurate, generalizable results. With us, for example, though, like the survey that I had you do for participation assignment number 1, that's only 50 people. So that's really not enough to be able to generalize to an entire society, or even to all of Purdue. Maybe we could generalize those results to people taking sociology intro classes in the summertime. But that's about it, because it's a very small sample size of only 50 people. But speaking of which, just for fun, I wanted to kind of show you some of the things that I found among our class. Let's see here. So this is an age distribution here. As you can see, most people fall in the 18, 19, and 20-year-old age category, although we have a fair number of 22-year-olds as well. As for gender, definitely most of you guys are males. It's about a 2-to-1 ratio of male to female there, which is surprising because in the liberal arts you tend to have more of a even distribution of males and females. So perhaps this pattern can tell us something about people who are taking summer classes, or people who take online classes, or perhaps there's some kind of theory behind this. As for ethnicity, the majority of you guys are Caucasian, but we have some other representation as well. Political views, I thought this one was pretty interesting. It's pretty close between the Republican and Democrat. About 38% Republican and or conservative, and about 29% Democrat and or liberal. About 6% of you are variable. You said it depends on the situation. About 17% of you are indifferent. And there were a few that I hadn't even heard of before, like distributists. That was a new one to me. So again, pretty even distribution. We're not too far weighted one way or another. As for major, we have a lot of engineers, not surprisingly. 20 of our 50 students are engineers. 10 are in the Krannert School of Management there. 5 are undeclared, and then we have a sort of distribution of a number of other subjects there. And I found this kind of surprising. I kind of thought in a sociology class I might get 1 or 2 sociology majors, but I guess a lot of people take this class as an elective, or to fill the core requirement. Semester-wise, we can see we have a lot of people that are freshmen in their first semester, but we have just as many people that are juniors in their 5th semester, so that's kind of interesting. The majority of people fall in sort of odd number semesters, which is a pattern we can find, indicating that most people probably started school in a fall semester, and so in the summer they're just beginning to start either their 3rd, 5th, or 7th semester. So that's a pattern right there. Reason for taking sociology: 65% of you are taking it because it's a requirement. I understand that. That's totally okay. 29% of you said you're taking it because you were interested in one way or another. That's very cool. Reasons for taking it online. This I thought was particularly interesting because I've never taught an online class, so most of you said it was because you were out of town. Another interesting thing I found when I was doing some comparisons is that among gender divide between majors, out of our 20 engineering majors, 6 are female and 14 are male, which is about a 2-to-1 ratio, which is about the same as the gender distribution in the class itself. And that's interesting because people typically say engineering is very male dominated, but in this class it's actually among the engineers the gender distribution seems pretty normal. So my video is about out of time here, so I'm gonna stop right here for a moment.